Hello children, I am Shishmita and welcome back to a new session. Ultrasounds are high frequency sound waves. They are able to travel along a well-defined path in gaseous and liquid media. We are going to learn more on this in today's lesson. But before starting, let's revise the previous session. Recapitulation. The incident wave, the normal to the reflecting surface, and the reflected wave at the point of incidence lie in the same plane. A reflection of sound arriving at the listener in more than 0.1 second after the direct sound is called an echo. A reflection of sound arriving at the listener in less than 0.1 second after the direct sound is called reverberation. Echo is used to determine the velocity of sound waves in any medium. Learning outcomes. At the end of this lesson, students will be able to know what is ultrasonic sound, different uses of ultrasonic sound, sonar, Doppler effect, keywords, ultrasonic, sonar, electrocardiogram, concept map. Ultrasonic sound is the term used for sound waves with frequencies greater than 20,000 Hz. These waves cannot be heard by the human ear, but the audible frequency range for other animals includes ultrasound frequencies. For example, dogs can hear ultrasonic sounds. Ultrasonic whistles are used in cars to alert deer of oncoming in traffic so that they will not leap across the road in front of cars. An important use of ultrasound is in examining inner parts of the body. The ultrasonic waves allow different body tissues such as organs and bones to be seen or distinguished by bouncing off ultrasonic waves by the objects examined. The waves are detected, analyzed and stored in a computer. An echogram is an image obtained by the use of reflected ultrasonic waves. It is used as a medical diagnostic tool. Ultrasonic sounds have applications in marine surveying also. Applications of ultrasonic waves. First, we will learn about the industrial applications of ultrasonic waves. Drilling holes or making cuts of desired shapes. Holes can also be drilled using ultrasonic vibrations produced in a metallic rod called a horn. This acts like a hammer, hammering the plate about 100,000 times per second. The shape of the hole is the same as that of the tip of the horn. Ultrasonic cutting and drilling are very effective for fragile materials like glass, for which ordinary methods might not succeed. Ultrasonic cleaning. We normally clean dirty clothes, plates, or other large objects by dipping them in a detergent solution and then rubbing and washing. Parts located in hard to reach places cannot be easily cleaned by this method. Ultrasonics helps in cleaning such objects which are placed in a cleaning solution and ultrasonic waves are sent into the solution. This causes high frequency vibration in the solution. These vibrations knock off all dirt and grease particles from the objects, which are then removed using ordinary water. Ultrasonic detection of defects in metals. Metallic components are used in buildings, bridges, machines, scientific equipment, and so on. If there are any cracks or holes inside the metal used in the construction, the strength of the structure or component is reduced and it can lead to failure. Such defects are not visible from the outside. Ultrasonic waves can be used to detect such defects. Now, we shall learn about medical applications of ultrasound. Imaging of organs. Ultrasonic waves have given doctors powerful and safe tools for imaging human organs. Echocardiography (ECG) is a technique in which ultrasonic waves reflected from various parts of the heart from an image of the heart. Ultrasonography (USG) is routinely used to show doctors the images of a patient organs such as the liver, gallbladder, uterus, etc. It helps doctor to detect abnormalities such as stones in the gallbladder, tumors, etc. It is also used to monitor the growth of a fetus inside the mother's womb. Ultrasonography is safer than older X-ray imaging technique. Repeated X-rays can harm tissues, especially those of a fetus. Surgical use of ultrasound. The ability of ultrasonic waves to cause molecules of materials to vibrate vigorously and to cause certain materials to break into tiny pieces, emulsify, is employed in ultrasound surgery. Cataract removal is a very common example. Ultrasound is also employed to break small stones that form in the kidneys into fine grains. These grains get flushed out with urine. This method has eliminated the need to perform surgery. SONAR. SONAR is the short form for sound navigation and ranging. It is used to determine the direction, distance, and speed of an underwater object with the help of ultrasonic sound waves. SONAR has a transmitter and a receiver which are fitted on ships or boats. The transmitter produces and transmits ultrasonic sound waves. These waves travel through water, strike underwater objects and get reflected by them. The reflective waves are received by the receiver on the ship. The receiver converts the ultrasonic sound into electrical signals and these signals are properly interpreted. The time difference between transmission and reception is noted. This time and the velocity of sound in water give the distance from the ship of the object which reflects the waves. Sonar is used to determine the depth of the sea. Sonar is also used to search underwater hills, valleys, submarines, icebergs, sunken ships, etc. Electrocardiogram (ECG). The electrocardiogram (ECG) is one of the simplest and oldest cardiac investigation available. It can provide a wealth of useful information and remains an essential part of the assessment of cardiac patients. In ECG, the sound variation produced by heart is converted into electric signals. Thus, an ECG is simply a representation of the electrical activity of the heart muscle as it changes with time. Usually, it is printed on paper for easy analysis. The sum of this electrical activity, when amplified and recorded for just a few seconds, is known as an ECG. Doppler effect. The whistle of a fast-moving train appears to increase in pitch as it approaches a stationary listener, and it appears to decrease as the train moves away from the listener. This apparent change in frequency was first observed and explained by an Austrian mathematician and physicist named Christian Doppler, 1803 to 1853. He observed that the frequency of the sound as received by a listener is different from the original frequency produced by the source whenever there is a relative motion between the source and the listener. This is known as Doppler effect. This relative motion could be due to various possibilities as follows. The listener moves towards or away from a stationary source. The source moves towards or away from a stationary listener. Both source and listener move towards or away from one another. The medium moves when both source and listener are at rest. Points to remember. Sonography technology uses ultrasonic sound waves to generate images of internal organs of the human body. SONAR stands for sound navigation and ranging. Whenever there is a relative motion between a source and a listener, the frequency of the sound heard by the listener is different from the original frequency of sound emitted by the source. This is known as the Doppler effect. The apparent frequency is the frequency of the sound as heard by the listener. Thank you for patiently watching the video.